Hi guys, welcome to this set of videos. These videos are going to follow along with the notes that come out of your book from Chapter 8, Section 1. What we're going to be doing in Chapter 8 is we're going to be taking a look at rational expressions and rational functions. Now we'll do very similar things to what we did in previous chapters here in Algebra 2. We'll definitely take a look at graphing rational functions and all the sort of things that go with graphing that we've done in all the other chapters. We'll take a look at transformations, we'll take a look at the characteristics and some of the key features that you'll find in the graph of a rational function, but all of that will come in later sections. We're going to get started here in section 1 by taking a look at some of the things we can do first with rational expressions, particularly simplifying rational expressions. So a couple of objectives or learning targets to kind of help us focus as we go through this set of notes. The things you guys will want to be able to do by the time we get to the end of this set of notes is you'll need to be able to simplify rational expressions, and that's where we'll start. We'll begin our discussion with simplifying rational expressions. We'll then move on to simplifying more complex fractions. You could actually sort of replace fractions again with rational expressions, and that's going to be where we get into sort of multiplying and dividing rational expressions. Now, a couple of things here about rational expressions. First of all, rational expression is just a fancy way of saying a ratio. A ratio, of course, takes you back to fractions. So what you're going to see is many parallels between what you guys learned about ratios and fractions in middle school and applying that here in Algebra 2. Everything you learned about simplifying ratios in middle school, everything you learned about adding, subtracting, multiplying, and dividing fractions in middle school. You'll see how all of that applies here in Algebra 2, kind of the connection. However, obviously this is Algebra 2, it's much more complicated because now our ratios are going to have polynomials in the numerator and the denominator. Now, speaking of polynomials, that brings me to the next thing you're going to want to watch out for. All throughout this chapter, we're going to do quite a bit of factoring. Now, we have already seen factoring in Algebra 2, and we're not actually going to learn any new methods of factoring, but you will need to know all of the methods we've already looked at. So, if your factoring is a little rusty, or you just need to brush up on it because you haven't done it in a while, let me direct you to some places you can go to do so. In Chapter 4, Sections 3, 5, and 6, we took a look at factoring quadratics. You'll want to be familiar with all of the methods that we looked at in that chapter and those sections. All of them will show up here in this chapter, including completing the square and quadratic formula. All right? It's all going to show up. And even beyond that, we did a little bit more factoring in Chapter 5, Section 5. In Chapter 5, Section 5, we dealt with polynomials, and we learned a couple of methods for factoring polynomials. Just sort of off the top of my head, we learned the group and factor method, the quadratic form method for factoring polynomials, and again, you'll want to be familiar with those because you will see them here in this chapter as well. So as we go through these problems, I of course will let you know which factoring method I am using, and you'll see me use it. But if you watch me, complete the square and you go, wow, I kind of remember that, but I'm a little rusty, right? You'll want to go back to Chapter 4, Section 5, where we did completing the square. Right there, I'll go through the theory behind it, explain it in much more detail, and kind of help you brush up on your factoring skills. So all of that is coming. Watch out for the factoring. And then, like I said, just in general, kind of the way we deal with fractions. And we'll start with this one. When it comes to simplifying a ratio. Now, we're going to have to perform a number of operations on rational functions. And the first one is this. You guys should remember from middle school, anytime we gave you a ratio, in order to simplify it or get it in least terms, you would have to factor out a GCF if you have one. So you look for the greatest common factor that the numerator and the denominator have in common, right? And so just as an example, if I give you the ratio 10/15ths, well, right away we recognize that 10 and 15 have a 5 in common. And so I factor the GCF, which is 5, out of both the numerator and the denominator, and we wind up with 2 times 5 and 3 times 5. Now, a couple of things here about the terminology that we use, but what is actually going on in algebra. The terminology that we're going to kind of use is you take a look at that and you go, oh, look, I have a 5 on the top and a 5 on the bottom, and they cancel each other out. And that's fine, and actually as we go through this section, that's pretty much the terminology we'll use, or I will use as well. When I get a GCF in the top and the same GCF in the bottom, we'll just say, oh, okay, those guys cancel each other out. But I want to make sure you understand what actually is happening here as far as the algebra goes. What's really happening is 2 times 5 and 3 times 5 can be rewritten as 2/3 times 5 over 5, right? Those two the product of these two fractions, right? Whenever you multiply fractions together, 2 times 5 is 10, 3 times 5 is 15. You multiply the numerators, multiply the denominators, and I get right back to 10/15. So this is just another way of rewriting 10/15 where I've pulled out a GCF of 5. But we know that in algebra, any number divided by itself is equal to 1. This 5 over 5 is actually just a 1 in disguise. And so this is equal to 2/3 times 1. And then, of course, we know that any number times 1 is itself. So here I just want to sort of bring to your attention is this. Yes, we will say, oh, look, those GCFs cancel each other out. Really, that's not what's happening. That GCF, right, is just turning into a 1. And any number times 1 is itself. And so while I'm going to say, oh, those GCFs cancel out, please keep in mind that that's not really what's happening. Those GCFs become a 1, and you're just left with whatever else wasn't the GCF. We'll take a look at that here in our first example problem. So let's just jump right into this. Of course, now the Algebra 2 version of it, you have a ratio. I have a numerator and a denominator. But as promised, that numerator and denominator are polynomials. I have a binomial in the top, a 2-term polynomial, and I have a 4-term polynomial in the bottom. I'm going to have to factor. So here we go. Let's just jump right back into sort of brushing up on those factoring methods and skills that we've got here in Algebra 2. First, let's start with the numerator. Take a look at the numerator of a 2x squared minus 10x. Well, a factoring method we learned back in Chapter 4, Section 3. In fact, the very first factoring method you should always look for this first is a GCF. And I do have a GCF, 2x squared and a minus 10x. I can pull a 2x out of both of those. So that's what I'll do. I'll pull out a 2x. That's going to leave me with an x minus 5 left over. 2x squared divided by 2x leaves me with an x, and a minus 10x divided by 2x leaves me with a minus 5. All right, so I factored the top by pulling out a GCF. All right, I go to the denominator now, and I have a 4-term polynomial. Well, this is going to take me to Chapter 5, Section 5, where we learned a factoring method known as group and factor. I take a look at these 4 terms, an x cubed, a minus 5x squared, a minus x, and a plus 5, and those 4 terms, they don't have a GCF that is in common for all 4 of them. But we learned this method of factoring that I can group them into smaller pairs and then look for a GCF in those smaller groupings, right? And so what I'm going to do is just simply group the first 2, group the last 2, and see if maybe there's a GCF then that I can pull out. So that's why you call it group and factor. You'll group them first, then see if you can factor those smaller groupings. And again, we looked at how to do that in Chapter 5, Section 5. So I'm going to group the x cubed minus 5x squared and the negative x plus 5. All right, so I group those those terms together, and now I look for a GCF, which I do have. X cubed minus 5x squared, I can pull out an x squared. So 2x times x minus 5, I can pull out an x squared, leaving me with an x minus 5. And at this point, I'm now feeling really good about I like my chances here because I have an x minus 5 in the top and I just got an x minus 5 in the bottom. I'm looking good. That looks great to me. Now I've got this negative x plus 5, and well, the only thing a negative x and a plus 5 have in common is a GCF of minus 1. So we'll pull out the minus 1. That leaves me with an x minus 5. And again, I'm feeling really good about this. I got an x minus 5, an x minus 5, and an x minus 5. Now again, a couple more things here about the way group and factor method works. After you've grouped the terms together and factored a GCF out of each pairing, what's left over, these leftover factors have to be the same. They must be exactly the same, x minus 5, x minus 5. If these leftover factors are not the same, either you made a mistake or you'll want to try a different grouping. Maybe instead group the first and the third term and the second and the fourth term together and try finding a GCF for those guys. But I got these factors are the same, so it worked and they match what I have on the top. So I'm feeling really good about the way this is going. Now again, the way that the group and factor method works is that I now take my GCFs, x squared minus 1, and those become a factor. And then the reason that the factors that are left over have to be the same is because they become my second factor. So I have x squared times x minus 5, and to finish off the group and factor method, my GCFs and the x minus 5. All right, now, like I said, we're going to go ahead and say, hey, look, I've got a GCF in the top, the x minus 5, and the x minus 5 in the bottom, and those will cancel each other out. Remember, actually, what it is x minus 5 divided by x minus 5 is just a 1, and 2x divided by x squared minus 1 times 1 is itself, all right? So we're going to go ahead and say that they cancel, but remember what's actually happening as far as the algebra goes. So anyway, what I'm left with is my simplified form, 2x over x squared minus 1. But now we have another sort of little catch that you gotta watch out for when it comes to ratios that I'll remind you of from middle school math, middle arithmetic, and it's this. Whenever you have a ratio, you cannot divide by 0. Remember, division by 0 is undefined. And so you're not allowed in a ratio to have a 0 in the denominator. It's no bueno. We don't like it. Well, you can't divide by 0. So, a couple of quick notes here about my simplified form. First note is this. Division by 0 is undefined. So here's what you're going to have to do on these problems, and here's what we're going to do. I'm going to have to restrict my domain. All right, here's what this means. Generally, when you have an expression, all right, you can choose any value of x that you want to. Pick your favorite number, doesn't matter what it is. You can plug it into the expression, right, and evaluate the expression. But in this case, what I've got to watch out for is values of x that give me a 0 in the denominator, because I'm not allowed to divide by 0. I will have to, what we call, restrict the domain. I'm going to have to eliminate the values of x that give me 0 in the denominator, because that's not allowed. So quickly here, just some of the terminology. We need to restrict the domain of this expression. And again, the reason we need to restrict the domain is because there are values of x that will give me 0 in the denominator, and that is not allowed. So I have to tell you, hey, you can pick any value of x you want to except these, whatever they are, these values of x, because they give you division by 0, and that's not okay. So here's how you're going to do that. In order to find those restricted values of x, we'll set the denominator equal to 0 and solve for x. Now, here's why we're going to do that. If the denominator cannot be 0, right? I do not want the denominator to be 0. Here's how you do that. Set the denominator equal to 0. Find the values of x that give you 0 in the denominator, and then simply tell me x cannot be these values. You can pick anything you want except for these values of x because they give you 0, and let's take a look at how that works. So here we go. Oh, 1 second. Here we go. Remember, our simplified expression is 2x over x squared minus 1. But I need to find my restricted values. What values of x are not allowed? And we said the way you do that is to set the denominator equal to 0 and solve. So my restricted values are going to be x squared minus 1 equals 0. Add the 1 to the other side. Take the square root of both sides, but don't forget, when you take a square root, you got to remember to do plus or minus. And of course, the square root of 1 is 1. So, guys, here's what's happening. If I were to plug a positive 1 in for x, in the top, 2 times 1 is 2. Awesome, no problem. But if I plug in positive 1 in here, 1 squared is 1, 1 minus 1 is 0. I get a 0 in the denominator, and that is not okay. Same thing with a negative 1. If I plug it in a negative 1, 2 times negative 1 is a negative 2. Fine, no problem. But a negative 1 squared is a positive 1, and 1 minus 1 is 0. Again, I get division by 0, and that is not okay. So what you've done is you have found the values of x that are not allowed. This just simply means you can pick any value of x you want to. Pick anything at all, except you cannot pick plus 1 or minus 1 because those values give you division by 0, and that is not allowed. So every time for these particular problems, when you're simplifying a rational expression, you will give me the simplified form 2x over x squared minus 1, and then you'll have to tell me the restricted domain by simply putting where x cannot be equal to plus or minus 1. And now I know, right, this is my simplified expression, and I can plug in any value of x I want to except a plus 1 or a minus 1, because that gives me division by 0, and that is not okay. All right, we will get a lot more practice with these in the next couple of pages of the notes, where we'll go through a number more examples of both refreshing how to factor and finding these restricted domain values, the values of x that I cannot use because they give me division by 0. Head on over to the next page of the notes. We'll try a few more of these. I'll meet you guys there.